Hey there, welcome to episode 23 of the Quaggling Sand audio program. I am your host, Dan Hugo, recording this on the morning of, April 16, 2024. It's a Tuesday morning. It's during the NAB show, which I will be heading to today in the afternoon. Very exciting, the National Association of Broadcasters. Today's episode is about me as a first-time programmer, my first official paid programming gig many years ago. My very first role as an actual programmer after my first year away at college, during which the Phoenix area had its hottest high temperature ever. And that record still stands, I believe, while I worked in an office with computers kept as cool as possible. That made for an interesting day on June 26, 1990. The links section of wherever you found this episode should contain approximately 4 links. There might be more. There might be more later when I get to the deployment stage of my various audio programs on their own websites. I need to link to where that is, etc. In the meantime, shameless self-promotion, buymeacoffee.com/DanHugo, wherein I have links to my various audio programs, some GitHub projects, other stuff, sort of a one-stop shop, out of band, not my own website, not wonderful profile page editor. You can find links to my various programs. You are under no obligation to buy me anything, though my projects are powered by coffee. Along those same lines, ko-fi.com, coffee.com/DanHugo. Similar idea. Once I launch the main websites, I'll start posting there. It's kind of like like a Twitter feed, I guess. You can post messages. They do not have an API. Neither of these platforms have an API for automated posting. So we'll see. Let's see how we make those work. But yes, both are ways to support the show if you want, but also ways to find my various programs and other efforts, projects, etc., which you may support merely by listening, watching, clicking, sharing, etc. No money required. That's how I roll. The hottest days in Phoenix, like I said, I've linked to the weather.gov website for extreme temperatures. Phoenix, Tucson, Phoenix's hottest day on record, which apparently still stands. I thought they touched it again more recently. June 26, 1990, 122 degrees at the airport, Sky Harbor International Airport. That means where I was actually working, which was very near Metro Center, if you're familiar with the Phoenix area. So several miles, I want to say like 10, 12 miles northish, like northwest, I think, of the airport. But it was hot. And I've linked to the Wikipedia page for the most famous horrible programming book on the planet, the infamous K&R, named for Kerrigan and Ritchie. It's called the K&R because of that. It is actually the C programming language. I'll tell you why I linked to it in a moment. First of all, to begin the show, the Pascal programming language. Nobody uses it. It was used for some things. I believe it was used for the Mac app framework if you were writing Macintosh applications. Some other things here and there. Pascal was not, it wasn't completely void of use, but it was not popular. And eventually, the rest of the world would realize that in college. But the point of Pascal in college was to learn how to program, not necessarily learn how to use tools in the real world, I guess. So my first year at Harvey Mudd College, 1989, 1990, was spent within the required CS5 course, Computer Science 5, learning Pascal again. Now, I had learned Pascal while helping a vision-impaired person on a VAX at Grand Canyon Community College when I was about 12 years old, so 7th grade, I think it was. I think it was 7th or 8th. I think it was 7th grade. I learned the joy of this old language, but on a Pascal system. So it was, if you've ever used a VAX, you know. So it was part of reasonably, so this part of my college first year was reasonably easy, though, we were paying to learn and I was not learning, so be it. I think everybody there was familiar with Pascal for some reason. So in hindsight, Pascal was not so bad as a starting point. In college, in Mud in particular, it was about learning how to learn, not learning one particular skill. So if you go to a boot camp, today's college replacement, I suppose, if you go to a boot camp and somebody taught you Pascal, you might say, well, why am I learning this? They teach you the tools that you will be using. It's like a vocational school. Here, in this case, it was an academic pursuit, so learning Pascal as a programming language. Pascal was fine as a jumping off point for C language, others. So it all worked out. My summer at iPro, when I came home for the summer, the job market was not smiling upon me. An opportunity, a referral for a summer gig came to light after a quick interview, and I mean pretty quick, with one person, the sort of the software manager, I guess. A summer gig was to be had. The iPro company, their main gig, I guess, their main service offering, as far as I could tell, was scanning in documents for law firms. They had reasonably high speed by standards of the day, high speed Bell and Howell monochrome or grayscale scanners. I think they were monochrome, but so you could feed in a document one page at a time. It would scan the document, pretty high quality, and save it, and then the company would archive these documents to worm drives. Write once, read many. Worm, not quite the CDR, which would come much later, but similar idea. They came in cartridges. They looked like how could I describe this? They were sort of square. I think they were square. If you know what a floppy disk is, it was like a big, thick plastic floppy disk. It was probably 5 1/4. I don't remember. But it just looked like a little white box, square, maybe about 1/4 inch thick worm drive. Yeah. So they would archive these documents. The person that owned the company would hire his kids and their friends, I guess, during the summers to feed the documents into these scanners. You just had to be organized, right? Boxes and boxes and boxes of file boxes. That doesn't sound right, but you know what I mean. Would arrive, and they were probably in high school, maybe junior high, and they would sit in a room all day and just scan documents. It's gotta be. How can you beat that, really, when you think about it? I didn't really associate with them. I was in a different part of the office. I didn't really hang out with them, but yeah, you could see the boxes were coming in. So they always had stuff to do. You just had to be organized for that particular task. Make sure you take a document out, scan it, put it back in the same box. So they may have done other things. I don't mean to oversimplify their efforts. I'm sure their efforts were essential. There were probably like 8 young people doing this. So cool. During my interview, which was reasonably brief, the one question, the linchpin, determining whether I would have this summer gig or not, was exactly this. Do you know C? Can you learn it? Of course, there was at least one yes to be had there. So I would immediately, on leaving what turned out to be a successful brief interview, I would immediately go to the library and I would find the K&R on the shelf waiting for me. Kerrigan and Ritchie to the rescue. The worst programming book ever if you're trying to learn a programming language. Now, I will point out, I started, I want to say it was right around June 20, June 19, something like this. So I remember interviewing, and then I would start like 3 days later. So if I was really stuck on the date exactly, I would have gone and checked a calendar for 1990 and seen which day I interviewed. Maybe it was like on a Friday and I would start on Monday or something like this. But essentially, I was going to be starting shortly, like days before what would end up being the hottest day in history still stands. Like I said, June 26, 1990, 122 degrees Fahrenheit, Sky Harbor International Airport. That's hot. I don't remember exactly what if you saw the temperature and you'd say, wow, we're in a different part of the city, so it's going to be 1 or 2 degrees cooler or warmer. I don't remember. I've also noticed that Phoenix, the weather has changed a little bit. It seems to be not quite as intensely hot, but it is very hot for more days, maybe. That might be my perception. One of my least favorite memories of Phoenix was when the low temperature is 100 right before sunrise, 100 degrees. It's going to be a nice day. So the office in which I worked contained several Everex 8286 machines. The fast desktop PCs. The 8286 was it was a reasonably fast processor for the time. They had a basic 4 mini computer. I believe they were using Novell token ring networking through the office, if I remember correctly. So, and various other computers, including the one I had. So they kept the office something like 70 degrees. It might even have been like 68, but they kept it quite chilly because computers of the day could overheat. There was no water cooling. There was no fan on the CPU. There was no big fans with big fins, no water cooling, etc. So the desktop PCs and this basic 4 and whatever else was going on, they had to keep the office at a nice chill 70-ish. And I want to tell you to this day, I remember quite clearly the sensation, the bizarre sensation, walking into an office that is 50 degrees cooler than outside, approximately. But, approximately 50 is 50. Though walking, okay, so when I arrived in the morning, it was not 122 degrees. It was very hot, of course, as usual, very hot. So it was at least a 30-degree difference. It's still significant. By lunchtime, it was pretty hot. So when I left to go to lunch, I walked outside, blast furnace. Like you open the door to go outside. It is insane. I would go outside, get in my Volkswagen Bug without air conditioning, try to hang on to as much of that office coolness, thermally speaking. Turn the quarter windows in so that there would be some breeze blowing on me of super hot air, of course. And I would drive, probably went home to my parents' house. It was, 5 miles away? So, yeah, 50 degree-ish. Then when I got back to work, after being in a home, probably around the same, probably 75 degrees, 78, something like that. Got back in my car, drove back to work, and walked into a freezer, a 50-degree drop in temperature. And it was shivering, like, whoa, geez, super cold. In the afternoon, the little side office where I had my little desk and chair, it's not very fancy, but I had a side door that I could go outside, like take a break. I remember in the afternoon going out there, same thing, freezing, hot, blast furnace, freezing, shivering, crazy. It was a crazy day, one that will live on in infamy, perhaps. So that was the typical work day. Not a 50 degree, but certainly a 45 degree. It was a particularly hot summer, 118, 115, 118. These kinds of temperatures were par for the course. Now, I think they count days above 110, which I believe are also stated on that Extreme Temps website. So you can see for yourself. But there are a lot of days that are above 110 degrees in Phoenix, so it was always hot. But I do remember that particular day with that temperature difference. Anyway, Summer of C. Getting that book about C in the library was essential, but it was also, again, the worst. The C language book is much more of a description, not quite a language spec, but pretty close. I mean, it's a language specification with some commentary. So they have the semantic diagrams and they have keywords and stuff, so it's pretty basic. It's not an official language spec, but you could implement a C compiler from that book, which Probably people did. I had an IBM PC XT on my desk running at just over 4 megahertz. You heard that right. 4 megahertz. It was like 4.1 maybe. I can't remember. 4 megahertz. IBM PC XT. Green phosphor CRT cathode ray tube. It's the good old days. Clicky keyboard, of course. And they were using Power C compiler. So this was a pretty low cost C compiler compiled for 8086 processors. Today we would say x86. So it was not free. They weren't using GNU tools, but I want to say it was like $50. It came with a nice book, also about C programming and about the compiler. And they basically, after I took my couple days to learn the basic language, which, by the way, I did not have on my computer at home. I had my Apple IIe, so my little 6502 cranking away at 1 megahertz. I had a Z80 card, so I could run Borland Pascal, and this was back when I was learning Pascal. So through high school, I had Borland to play with. But I didn't really have a computer to play with C. I didn't have a C compiler for my Apple. So I basically just assembled, or compiled, I guess, the functions of C in my head. Then I got to work, start my new job. And here's the compiler. Here's your computer. Here's what we're up to. And so I started learning how to program. So I, probably wrote the equivalent of Hello World to situate myself. So yes, I can compile some code. Yes, I can run it. I can see how it works. The Power C compiler was pretty for the price in the day, the time. The open source software was a thing, but it wasn't what it is now. So for being a reasonably low cost compiler, it was pretty featureful. So it had a source window, an object debugger, so you could actually step through code that was compiled. So I could watch my code executing in the source window and also watch the individually assembled instructions. So that is, I could watch print hello world, and I could watch the execution of that C statement. I would go through and pick up the string. I could watch it parsing through the characters, hitting the null, calling the print function, stepping into the function, watching. So all this I could actually watch. So now I was able to see, when I wrote some piece of code, I could see what the processor was actually doing. This is very unusual. I don't think people do this anymore. But it was extremely, if you're going to learn how a processor works and how compiled code works, it was absolutely valuable to learn what's the mapping of the code I write, the C keywords and the function names and a lot of ifs, a lot of if then else. We'll get to that in a second. But to be able to watch and see what the processor was actually doing was really, really informative and educational. So that's a skill I would use many times in the future as an embedded programmer, doing pre-silicon validation at Intel, that first time I worked at Intel. Generally being aware of how computers work. So this was rolling up your sleeves and really watching how all this was working. Really invaluable. We didn't learn that. So at college, we had a Pascal class, of course, as I said. As my junior high days, Pascal experience, we were learning Pascal on the school VAX, HMC VAX. So in this situation, you write your code and you submit it to run. Not quite a job, but the VAX is almost like the mainframe mentality. So you'd run your code and you'd get some output, and I'm sure there was a debugger somewhere, but at this level you're doing print debugging or write line debugging. So you're able to figure out what's going on, but you're certainly not watching VAX instructions at this point, right? So having the ability to watch code execute on the processor itself, watch register, memory moves, ALU operations, et cetera, watching all this take place, watching memory, watching stack, seeing how stack pointer moves around, really useful. So a fundamental, so this is the part where you learn how to learn, and then you go and learn. So this is why I say the Pascal experience, while not practical, again, was not learning a true job skill, but that's not really what college is for necessarily. Not your first year. You're learning how to how to build, how to make, how to learn, how to research, how to study. Because essentially college should be you're handed a lot of things you don't know. So you learn how to deal with that, and that's how life is. So Pascal turned out to be useful in that regard. But I remember at the time, the class behind us, so when I returned from learning C over the summer, the freshmen entering, I think they were still doing Pascal, but they were about to transition to teaching C. And I was like, yeah, definitely worthwhile to learn C instead of Pascal for the job world. But again, still useful. So I learned C. Was I self-taught? No. I'll get that in a second. So the project I was working on during the interview, the project we discussed was this. They intended to use these Bell & Howell scanners, which were pretty fast. I don't know what the page rate was, but you could feed in a legal size document. 11. What is it? 11 by 17? No, that's too big. 8.5 by 14. Is that what it is? Anyway, you could feed in a document full of text or whatever. It would scan the document. You'd get a fairly high resolution image, maybe a second. You could maybe do 50 pages a minute, something like this. So at the time, that was pretty quick. And you're dumping that data onto these Everex 286 machines. They're storing them away on a token ring network, file server somewhere. It's all good. So they wanted to experiment with using the scanners to process survey forms. So the example at the time that I recall, suppose you receive a postcard in the mail, answer the survey, you fill in a bubble, like your Scantron tests of old. So you fill in yes or no or whatever. Then you send it back. So you, instead of getting big document boxes, you would get smaller survey postcard boxes. I don't remember if it was going to be a postcard, but it was more. I think it was more than one question, but not Scantron size. So you're not going to be parsing 50 or 100, 25, 50, 100. You're 10, 5. But either way, because it was not a full size document, it was going to be a smaller postcard size or something similar. You couldn't guarantee that the input document would be square, so it could be rotated a little bit if you didn't put it in perpendicular to the tray. So the idea was, can we now? Of course, today this would be trivial. Not even funny how trivial it would be. But at the time, the question was, can we insert a postcard, orient the incoming scans? You'd scan the document, it would be at whatever rotation. You'd have to either unrotate it or rotate your bubble scanning grid. And again, today, trivial. Figure out which bubbles were filled in and then move on. How fast could that be done? They wanted a particular rate. I don't remember what it was. We got to do maybe 50 a minute, maybe 100 a minute. I can't remember. So at the time, I didn't really know. I didn't know anything about QR codes. No, nobody did. Registration marks, of course, would have been the key. You locate the registration marks. You apply a rotation. You could rotate. Rotating the image might be too slow. You probably rotate your grid that you're checking. Now today, of course, you would use some sort of machine learning. You'd have the machine learning model take the input and look for which bubbles are filled in. So magic. So at the time, that was my goal for the summer, was to write some code to do this as an experiment. But very quickly, I was handed a different task because that's how I am. That's my career path, has always been the thing we hired you for. Yeah, don't do that. We have something else. So I pivoted. They needed someone to write some code to parse word processor documents. So this would not be even touching the scanner. Although, I don't know if any of them were OCR'd. Optical character recognition, they may have been. But as far as I'm aware, they were all like WordPerfect and Microsoft Word. Early days for both of those things. WordPerfect was the more popular word processing platform. And I want to say there were like 10 different formats because each person writing a deposition would add their own variation. So the people typing up these documents would use slightly different formatting. To the casual observer, if you were to print it out, you'd be like, oh yeah, deposition. But in this case, the goal was to break the blocks of text. So you wanted to get the header, which was like the date and who the subject of the deposition was, and some other cursory information. Usually, if you look at a deposition from those days, there would be like parentheses as one form of marking this block, this header block, right? It's like a title block on a drafting document. So there'd be that somewhere in the top part of the first page, probably on the right. There'd be some other information. Then the text would start somewhere, and it would be deposition style text, right? Question, answer, etc. So the idea was to break it up into summary blocks for this software tool they were using so that you could scan through deposition questions and answers, a certain size, right? So imagine breaking a document down into tweets. Like, I want to post this as 1,000 tweets. So break the document into 140 or now 280 character blocks. So that was the goal. So the challenge was each file, like I said, was in a different format, and I knew nothing of regular expressions. And I was just new at programming in C. So I essentially spent at least July learning how to program, learning how to deal with these different document formats, learning how to arrive at document similarities, document differences, being able to identify basically who, based on the pattern, based on the layout, which could vary, figuring out basically, oh, this must be this kind of document. So there was still some horrible assumptions. But the way I approached it was, okay, if I can establish what the layout of the document is, I can then figure out where the deposition components are that I want to put into these summary blocks, and I would output the blocks. So every time I processed a page, I would print a period. So then I could watch pages being processed. And on my 4 megahertz IBM PC XT, you would see dot, 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 dot. So I wrote all this code, and it seemed to work. Like, I would just test it on, I didn't really have automated testing at all. So I would just run, eventually it got to the point where I would just take one of each kind of document, run them through, watch the dots. I would check the output. Yep, did what I wanted. So the code worked. And this is one of those adages that comes out. If the code works, good enough, right? It accomplishes the task. I wasn't writing a code library to be published. Luckily, this was not really intended to be a shipping product. It was utility for in-house use. It would have been a major nightmare to maintain. I'm going to assume that at some point someone either rewrote it or chucked it completely. Somebody somewhere should have said, why are we not using regular expressions for this? And then later, today in modern times, although iPro is not in business anymore, as far as I'm aware. But today you would just, you'd run documents through a classifier. You could literally say, oh, this is probably this format based on machine learning, right? Train some documents, like each of these formats, each of the people, each person who was creating these documents with a little bit of flair applied. You just take a sample of each, run it through, come up with a model that could classify documents. Then you would say, oh, this is this kind of document. Then the chunker that would break it up into blocks could run through the document with high certainty of what the document format was, where the different blocks of text would be then in this document, et cetera, et cetera. So nowadays, the task that I spent all this time on, which a lot of learning the programming language itself, probably could have been done in a day. And saving grace, though, because I was even at my young, was I 19? I was still thinking, I hope I didn't waste their money. I don't know if I was probably making like $10 an hour, maybe. I feel so, I wasted, I feel like this took too long or whatever. So we loaded up my code on one of these EverX machines. and they had a bunch of documents. So, and I wrote code that, the code was written such that I could just take in all of the documents in a directory. And again, printing out, so it would print out the file name, carriage return, or line feed carriage return, new line, and then it would print out these periods. So you'd have some idea which document you're processing, how fast it was going, then on to the next one. So print out a blank line, then print out the next file name, and so on. So on my tiny little PCXT, it would take a while. If you were going to do a directory of like 100 or 1,000 documents or whatever, you go to lunch. But on these fast machines, they ran my code, and it was ripping through them like that. Like I remember thinking, wow, unbelievable. And whatever their bill rate was, because these are law firms, right? So you're charging per page, per some standard billing. So it's either 6 minutes of time per block, or it was each page, etc. So when we actually ran this, we actually watched pages being processed. I did a quick, back of the envelope, and I said, oh, just this sample run paid for all my time that I spent writing this code, because I was cheap. But it was still interesting. It was definitely a learning experience. It was not code that I would be proud of, other than, and again, like one of these, I'm sure there's a better worded adage, but the crappy code that I wrote got the task done and paid for itself in a day, maybe a couple hours. Certainly, like I said, the run that we did that I was watching paid for my time essentially, or at least half. Right? It made short work of my billable time. So it worked, got the job done, did what it needed to do. I remember the person that ran it was like, hey, look, yeah, it works. He was happy. I was happy. Things worked. So that was fun. So that was an interesting summer. Then we got back to the rotating the postcard thing. And I remember in what would be the first of those, like, I could have done better on that. I remember saying to them, well, it would take a long time to do the rotation, because you basically have to apply a rotation matrix and see if you can find the orientation. So I was using the edges of the postcard. I really didn't even think about saying, hey, if you put registration marks, we'll have a positive orientation determination. We can actually measure that and then apply a transform. Done. So I think it would have been actually doable, but I did not approach it that way at the time, because what did I know? I'm fairly certain that the guy who interviewed me, who was kind of their in-house coder, he probably just went off and did it. I have a feeling when he had some time, he probably wrote some code, did a little experiment and everything. Hey, maybe what I told him was helpful. Who knows? But so I never actually worked on the rotation part. That would come later in my career, doing something similar to that. The magic of matrices. So I learned several things from this first job experience. And I should point out, just to be transparent, I guess, my first real programming job was the summer after I got my, or was it summer, when was it? Probably my senior year of high school. It wasn't the summer. But it was near the summer. I drove up to Flagstaff, Arizona, where a professor with whom my horrible uncle had taken several classes. So I went up to there, and I wouldn't say I programmed. I took a lot of sample code for an image digitizer. This was not a true, like, it wasn't digitizing images. This old school device would project a frame of film onto a transparent surface, and then you would use a stylus, which was, it was a little, like a loop, like a little lens with a button that was on a bar that could move horizontally, and then you would pull it down or push it up, and the loop was attached to this bar on a memory metal type thing. So the metal, the little strip of metal, would roll up, or you would unroll it. So you'd move it down, it would unroll. Push it back up, it would roll up, and it would measure the position of the loop based on the metal unrolling and rolling, and then of course the horizontal along this bar. So you get an XY coordinate, you click it, done. So this was an exercise physiology lab. biolocomotion in mammals and birds and whatnot. So they would take pictures of birds or people, and they would mark the joints. The birds, I think, was a sample experiment, but in this case, it was going to be humans trained, running, probably on a treadmill. So you'd capture their marked joints. So you'd go through every frame and mark where their head, their shoulder, elbow, wrist, torso, hip, knee, ankle, right? Probably for each. So in the image, if you could, I don't know if they captured just one side, but ideally they would have captured all visible points, right? So the code that I entered, I didn't really completely understand. I understood it by the end, what it was doing. But I took a lot of code, put it in, made it work. It was a pile of like business basic or something. So it was a lot of array math. So it was so basically getting it working with this scanner was the tricky part. So got the code working, got the scanner connected to the computer so that I could capture the data, would take the data, save it to disk. So I got it working. So technically that was my first paid programming gig, but it wasn't like sitting down and authoring some software to accomplish a task. It was really more integration of some existing code that was not, it was on a printout, so I had to actually type it in. So it was getting essentially some sample code, integrating it with the hardware, and getting it running, and then actually saving data and all that stuff. So like I said, more integration, not really a true programmer job, but that was my first like hands-on technology job. It was before I went off to college, so I could only begin to guess what learning how to learn would actually look like. But that was fun. But yeah, my first official programmer job, paid to be a programmer, summer of 1990. What did I learn? I did not teach myself to be a C programmer. No. My colleagues, my project progress through my career where I was writing C code and we hit milestones and code worked and we fixed bugs and I had to write code that other people would also be using and writing their code to fit with, right? So a team of programmers. Those are the those are the people who teach how to code. You learn from your colleagues, you learn how to work together to collaborate. Merely learning from the C programming language book, the K&R, learning from that book, you could say you're self-taught knowing the language, but not how to use it. So I did not teach myself how to be a C programmer. I taught myself the C language based on reading this book and by sitting down at a compiler and watching code execute and watching what the processor was doing. It's like learning how to drive a standard transmission in a parking lot. You know how to make the car go without stalling mostly, but when you get back on the road and you learn with other people around you, suddenly stalling, getting into first is something that can cause real problems. So you learn very quickly how to actually drive. So you learn how the transmission works in the parking lot. You learn how to drive the car with other people on the roads. So I did not teach myself C. So when I hear that people are self-taught, and my joke is always, I don't mind people who are self-taught, but it's the teachers I have a problem with. It's very difficult to truly learn by teaching yourself anything. That's why when people learn a new language, they want to have a conversation with somebody who speaks the language more natively than they do. You can read, you can listen to recordings, you can practice saying words, but when you interact with somebody who speaks the actual language, you will learn how the language really works. So that applies to programming as well. And another thing is I didn't really teach myself the C programming language in isolation. So when people say they're self-taught, once again, they are standing on the shoulders of giants. So I had learned BASIC when I was in 6th grade. Was I self-taught then? Well, I got a book on BASIC, and there were 2 other people. So we had 3 computers. 3 of us were playing with the new computers in the library because we were all bored in our schoolwork. So yeah, go play with the computers. Go learn how they work. So we kind of co-learned with each other, right? So, hey, how does this work? Oh, I'm trying to do this. And you look over their shoulder. Oh, no, that should be that. Okay. So we're sort of self/co-learning basic. And basic, the beginner's all-purpose symbolic instruction code, BASIC. Basic was created exactly for that, to learn how code works. Then I would go on to learn Pascal by sitting with a person with vision impairments, and learning how Pascal worked on a VAX. Out of curiosity, I learned how 6502 assembly language worked on my Apple IIe. Got that Borland card, got the Pascal compiler. Got the Z80 card, got the Borland compiler running on that. Kind of learned how the Z80 worked, which of course was 8080 compatible instructions anyway, mostly. And learned how computers worked in general. The open architecture of the Apple IIe was a part of that. As Newton said, and as I've already suggested, and I will paraphrase here, we see farther by standing on the shoulders of giants. So while I did my part, it was only because of the other parts that made my learning possible. I did not sit down one day and say, I'm going to create a new thing that no one has ever seen or heard of, make it work. That's self-taught people who do those things. They're operating in the upper three echelons of the Bloom taxonomy, right? They're creating, they're synthesizing. So as a self-taught, not C programmer, but self-taught user of the C programming language, I had done nothing more than build on the other learning that I already done. So this is totally normal, not diminishing that. But when I hear of people self-taught, I taught myself how to be a web developer. Okay, yeah, we'll see. So I'm always skeptical of that, because there are ways to learn how things work, but then you can also learn how they really work. And I think self-taught, it's very difficult to learn how things really work until you actually put them into practice, and then you start to learn reality and how to actually make use of the basics. No pun intended, but how you can learn you learn how to cook macaroni and cheese, but when you serve it to somebody else, you will know if you have more work to do, especially if they tell you. So the real take home from that summer was, I did not know how to do the thing that the job entailed. Do you know C? Nope. Can you learn it in what would essentially be 3 days? No, I couldn't learn C in 3 days, but could I learn enough in 3 days that I knew whether I could learn more through the summer? Yes, and I did. So the fact that I did not know what I was getting myself into was not a reason to not do it. So not knowing is the best reason to try to do something, because you will learn. Maybe you will learn on your own. Maybe you will learn from others. Collaborative learning probably would have gone a long way in that case if I wasn't in a side office by myself. So that would be another take home is, the whole purpose of a hackathon. You can do a competitive hackathon, but a hackathon to attack our projects at the Innovate for Vegas Foundation. Part of the goal there was to collaborate with others on a team. The notion of a ticking clock, like we have Saturday and Sunday to work on projects. So it wasn't a race, but it was certainly, hey, we're going to try to accomplish what we can in this weekend that we have every month with our co-work space and so on. So not knowing how to do something, but if you have others around you and you can learn together collaboratively, share knowledge, like, oh, I know how to do that, but I don't know how to do this, et cetera, et cetera. So not knowing is not the reason not to do something. If there was one point in my personal timeline, in my career or in general, that validated my educational path, college and otherwise, so Harvey Mudd was sort of a weird choice at the time. It's right there in the name, kind of odd. But okay, this little teeny tiny school that's about the size of a large high school campus. Maximum student size at the time, I think, was chartered at 800 or 600. I can't remember. My dorm had 88 people in it. My classes, you'd know everyone. This was unheard of. I remember telling someone a story. I said, oh yeah, that guy Craig, this and that. And she stopped me and said, wait, you know everybody in your class? Like, yeah, there's 151 people entering. So freshman year, 151 people. You knew all of them, at least by name. That was not difficult. So making that decision of following that career path This first programming job was the first kind of real world experience where you're going to apply things you learned in college, but they were not the things you learned in college. You would apply what you learned in college. And this would apply just in general. So that's a learning experience. I learned that I had a lot to learn about C programming, about how to tackle problems, how to factor them, how to make use of the tools. The if-then-else approach to the decision tree could have been done much better. The code could have been less coupled to the document formats, obviously. Comparing the tools available to today to the time. So comparing, like I said, the machine learning, the parsing text at this point is trivial, right? So learning then and knowing what's available now and the difference, night and day, I think value in today's, we'll say, more experienced programmers comes from recognizing this difference, from not having code written for you by a copilot or by some other code generating machine learning, artificial intelligence, whatever. Knowing how things work, knowing how processes work, how document parsing could work, making use of regular expressions if I had it to do over at the time, et cetera, et cetera. So rolling up the sleeves and learning how things work and learning how to learn about how things work, knowing what to do when they do not, et cetera, et cetera. Tackling this task I was given without specific skills required up front and acquiring them to accomplish the task. The beginnings of this knowledge again. So I recognized more so that I had a lot to learn by doing, was extremely valuable. So my first programming job was indeed the beginning of the beginning. And by the end of that summer, I was not quite to the end of the beginning, but I certainly learned the value of learning how to learn, how to factor problems, how to tackle the components I did not know. And, like I said, if I had it to do over again, I would have tried to do collaborative coding more. And I did ask that programming manager questions now and then, but I was essentially off on my own. Not a cubicle, a larger space than that, but essentially off on my own on the side office. Not ideal. Some human interaction, some ideation, some sharing of approach ideas, some code review, etc. would have been more valuable. But this is how you learn practically, which I did. And so I've probably applied a little bit of these things throughout my few decades now. So that was my first programming job. Very educational, a long time ago. And it included the hottest day ever in Phoenix, Arizona. My first computer. Now, before that, I had worked at McDonald's. I had worked at Fuddruckers. We worked at Toys R Us to build the store, and then they laid everybody off. So if you were in the crew setting up the shelving and stuff for the Toys R Us near Metro Center, doesn't really matter. It didn't last too long. It's gone. I had these, manual labor, service industry, cooking hamburgers at McDonald's. That was, I would not have recognized the 50-degree temperature difference as much because there wasn't one. It was nice and toasty over that grill. So my first programming job, including the 50-degree difference, was something of an eye-opener as well. So that's where I'm going to leave it today, this April 16, 2024, the story of my first programming job. Don't forget to check out buymeacoffee.com/DanHugo for more information on where to find my episodes when I create the primary point of publication, the website for each of my current productions. There may be additional shows. I talked about this in my most recent before this week. I think it was episode 59 of the Cafe Genius Impresario show about adding possibly a video sort of interview discussion called the Advocatus Diaboli, the devil's advocate. So we can be cynical and deconstruct some of the crazy things going on in our entrepreneurial ecosystem in the greater Vegas area. The Let's Innovate for Vegas audio program could also have an additional video stream if we do some live coding or if we get back into doing some hackathons. We do have office hours every week, which are not recorded, but we could do some sort of recorded version of some discussions, ideation, especially as we design projects and stuff. The current project is hopefully going to be more about a progress than blue sky for the Let's Innovate for Vegas program for a little while. So all this and more. So you can start at buymeacoffee.com/DanHugo. Check out that, and we'll see what kind of updates appear in the coming days, weeks, and months. And on that note, I thank you again for listening. Take care until next time.